Hey everybody, in this video we're going to talk about solving an equation of the form log base b of a equals c. When we do these problems, what we're going to want to do is eventually put it in exponential form. But these problems are going to end up getting a little more complicated than what we have here. So let's go ahead and go through the list of what we're going to do with these types of problems. Step 1 is to first isolate the logarithms on one side of the equation. Let's go back to our problem here. We already only have log on one side of the equation, so that's good. Next is to use the properties of logarithms to write the equation in the form log base b of x equals k. So basically we're going to put everything inside of one log. Now for what we have, everything's already inside of the log, so we're good there. Now we want to write the equation in exponential form, and then step 4 is going to be to solve the equation, and step 5 is going to be to check. So let's go ahead and do step 3, which is to write in exponential form. So 10 to the negative 1 is going to equal x. Now we can solve for x. This is just 1/10 equals x. Alright, now we have to check. Step 5 is to check. So if I plug in 1/10 for x, is it going to give me a negative inside the log? No, it won't. And that does end up equaling -1, so that works there. For the next problem, step 1, put all logs on one side, check. Step 2, make it so there's only one log by combining the logs. That's already done. Step 3, rewrite in exponential form. 8 to the 1/3 is going to equal x. And now solve for x. 8 to the 1/3 is the same thing as the cube root of 8, and that equals x. What is the cube root of 8? It's 2. Now, if I were to check, I would plug 2 in for x, and that's not going to give me a negative number inside of my logarithm. So I know that 2 is a valid solution for this equation, log base 8 of x equals 1/3. Here's some more examples, but this time what do we notice? I noticed that x, the base, is what I'm solving for. Right? But the first step was to get the logs, all logs on one side, which there's only one log here. And the second step was to combine logs. There's no combining that needs to be done. Third step is to put it in exponential form. So the base is x, the exponent is 5, the argument is 32. So x to the 5th equals 32. Step 4 is to solve for x. How do we do that? We do that by taking the 5th root of both sides. So we get x equals 5th root of 32 is 2. Now we can have a base of 2, right? Base 2 of 32 is going to equal 5. What we can't have in a base is a negative number. Our base has to be greater than 0. Okay, and not equal to 1. Alright, let's take a look at this next one. Steps 1 and 2 are done. We'll get base x to the negative 4 equals 1/16, which is 1 over x to the 4th equals 1 over 16. Negative exponents go into the denominator. Now, I can multiply by 16 on both sides and then multiply by x to the 4th on both sides. I get 16 equals x to the 4th. Now how do I solve this? I take the 4th root of both sides, and I will get plus or minus 2 equals x. But what do I know? I can't have a negative base, and x is my base. So I have to have the only solution as x equals 2. And that's how we can solve the equations if we are given a simple form, log base b of a equals c.